Gary Rosen and with Carlson Software, and I want to just thank you all for taking the time to attend today. We have, I think, a really outstanding presentation for you today. I'm really excited and honored to introduce Bruce Carlson as the president and founder of Carlson Software, and Peter Smart is the president and founder of HydroCAD Software. And I think we're really in for a treat today, and these two gentlemen are going to show you the two softwares working independently and working together. It's a partnership we're all very excited about, and we really think we can show you some exciting stuff today. So you can listen online or with the phone. You can type your questions, and I'll be reading those to the presenters at the end. And I don't want to take any more time. I'm going to turn it over, and stay tuned for some really great stuff. Okay, take it away.
Thanks, Gary. This is Bruce. We're really pleased to be working with Peter Smart of HydroCAD, and this webinar will show some of the linkages to the HydroCAD product and also show operation within the Carlson Hydrology module. Now, if you look to the right, this chart is a roadmap on how to approach detention pond sizing in the Carlson Hydrology module. On the left, we have a classic subdivision developed site that has a defined watershed shown in blue. And the starting point for this process, internal Carlson Hydrology, and for feeding into HydroCAD, begins in the watershed pull-down, defined watershed layers. Can't say enough about this very first command in terms of its critical automation. So when we note that we can do our watershed runoff analysis by the rational method, but in feeding into HydroCAD and also for detention pond sizing in general, we recommend the SCS method. And if you click on HydroCAD layer designations, which are several pages, which have this form. I have a short form so you can relate to it easier for this example. This is a HydroCAD look, if you will. Okay, we're going to do the SCS method. And then in addition, your eyes need to go down to this lower zone and note some of these layers for of the automation. For example, we can have soils. If I move this out, I have soil boundaries with soil types designated by A, B, C, and D, simple letters within boundaries that don't have to be closed polylines. They just have to meet and enclose as separate lines or closed polylines regions. Layers. These soil maps are available on NRCS sites and various state sites all across the country. The country is almost fully mapped in terms of available electronically. So what we've done is we've said the soil line work layer is in soil groups. The soil label layer is in soil group letters, and this can be defined by you for any layers that you choose to use. In addition, the watershed line work is in subcatchments. So this blue watershed here is drawn in the subcatchments layer. And we've even drawn a runoff is calculated by our runoff command in the layer subcat flow lines. So everything is accounted for here. And just for a quick look on, for example, the red roofs on these buildings, if I click on HC roofs and hit edit, you see a patch, color red. I have a 95 runoff curve number, and it's coming from a library, editable, which has distinct runoff coefficients or curve numbers based on soil type. So when you have woods, for example, good woods, here we have good woods would absorb more of the rain, let less runoff, lower runoff coefficients or C factors, curve numbers. We have quite variable results depending on the soil type. Okay, so this is how each one defined up here. Now it leads to this hatching. If I clear my hatch, you see it goes away. So this hatch is primarily a verification tool to be sure that it looks good. And I just hatch them all again, and I'll hit OK and exit. So this starting point, both the hatching up here and the layering down below, set up the entire automation process. Now, we'll review this procedure. First, taking it, and then we'll go through individual items. Now, one time, that's why it's in, we have the one in parentheses, you need to determine your rainfall event, rainfall frequency and amount, set your rainfall for the calculation of the detention pond sizing. You're going to use the 100-year event, 50-year event as second. Then, twice, you would do your curve numbers and runoff. Once for the pre-construction condition, and again for the post-construction, leading to different curve numbers. Now, I've got my answers here that we will recreate on the fly, but reference. Then you do the time of concentration also twice for the pre-construction and for the post-construction. Then you do your peak flow twice, pre-construction and post-construction. Then you, focusing on the post-construction, note your runoff condition, post-construction, and just as a point of information, what size pond would store all the post-construction runoff, in case you have no intention of reducing the flow and just want to capture it all. So it's worth taking note of that, and that is reported in one of our watershed pull-down commands. Then you go to detention pond sizing, which is located under the structure pull-down. These other ones referred to here are located under the watershed pull-down. Let's go and find them ahead of time. Rainfall frequency and amount. That's this first step. Then we do curve numbers and runoff. Had you been doing the rational method, you would drop down to the calculate C factor. But for detention pond sizing, we highly recommend the SCS method. Curve numbers and runoff lead to the CN values, pre and post construction, and also your runoff and ponds, all the water, if that was your intention. Time of concentration, right here, we're going to do the simple SCS method. It is objective, maybe not as subjective as the TR55. It comes from the DTM aspects of the overall watershed area. This highly automated SCS method versus doing the TR55 method, which drills into sheet flow, shallow concentrated flow, and other aspects, channel flow. Then we're going to, with these bits of information, we have all the inputs necessary to slip over to detention pond sizing. So I'm talking first here about a roadmap. Get your layer designations going. You can use the runoff tracking command to find your longest runoff distance, which is important for this process. Then you drop down to rainfall frequency and amount, curve numbers and runoff, time of peak flow, exit over to detention pond sizing. That's the procedure, TR55 method, to stay in the SCS world. Now, with that lined up and a recommendation from that routine, slip back and go further down the watershed pull down. Go to Hydrograph Routing, SCS method, to get a hydrograph file of the post-construction runoff, and then use that as an input into reservoir routing through a designed pond with outlet structures, which give you a stage storage curve and stage discharge curve, which then, through the reservoir routing command, lead to final verification that you've got the right stage discharge to reduce your post-construction flow from 30 CFS in this case down to 8 CFS, the pre-construction condition. Okay, so the roadmap's important. A map and how you work your way through the package is critical. Now we'll do a few of the commands. Certainly under rainfall frequency and amount, that's very easy to do. I've already made a tin, by the way, out of this. And I should point out, when you make a tin file of the surface, it is best when you have nothing but a contour map to work from, which are high and low streams and ridge break lines to yourself as 3D polylines. I have that particular stream break line. I have sort of a ridge break line over here, another stream break line, and they help draw the water in, get a more accurate surface for the involved. Okay, frequency and amount is very straightforward. You pick this command, select point on the map, or go find my state. I'm very familiar with where we're located, Maysville, Kentucky. I'm going to do 100 year 24 event, pick just around Maysville, and get roughly 5.76 as a rainfall in inches. All right. Now I would go straight to runoff. Now what I'm going to do is increasing automation. And to continue the roadmap concept, I'm going to do this in the regular watershed and structure pull downs. And then I'm going to reveal the added automation found under HydroNet Explorer, which is also the doorway into HydroCAD. So I'm heading there ultimately, but I'll go there to go all the way through this process as already outlined. Okay, so the next thing we're going to do is get those curve numbers. That's the next on our list. We have our rainfall, roughly 5.8 inches. The area, you can compute that boundary as 22.9 acres. I want to get pre-construction curve number and post-construction curve number. Okay, let's go in and do the pre-construction, what I would call the old-fashioned way. The first thing I'm going to do is go to View, Isolate Layer, and isolate to my soil, 2 layers involved, line work and letters, and to my watershed. Then hit Enter, and there you see the soil zones laying in behind. Now here's what I would call the old-fashioned method of doing this. If I come into curve numbers and runoff, I can clear what's there, switch to an acres mode, and select my curve number. Let's say the entire site was good woods. Good woods. So we go down to woods, but it's different soil types as you see. So I go to woods, good, and focus on A first by clicking A down here. Now I've got the zone, but I don't have the area. To get the area, I can do sub-area by interior point. All right, so I look for A's. This is an A here. Include it, yes, but I'm not done. I can kind of scroll in and get that little bit of A there. Include that, yes. I can come back out, and there's a little bit of A coming through over here, and I get that one. And that's good, and I hit Enter. Look at the command line, Enter to end. And I've got my entire acreage, 10 acres of the A zone. So I go to my second line, select my curve, how it was done, in the old days with our package before increasing automation, but you need to witness this. I hit B, and I'll complete that process. We'll click into it and pick some sub areas by interior point. I hit the B here, use it. I got some more B over here, use that one. I can see some B down here and use that one. I think that's it for the B, and hit Enter and continue on with select curve number, and you're getting the idea here. That's the purpose of these webinars, is just to get the mechanics of the process. This is soil type C in my good woods. and I click into that zone, so I know that my sub-area picks are going to go to that particular zone, and I pick sub-area by interior point, and let's get some C. We got some C here, and that found its way all the way around. That's good. And is there any more C? A little bit here, it looks like. And I think I've got everything but the remaining D at this point. Hit Enter and wrap it up with select number. And this is a little bit redundant, but you get the idea. We'll hit that and click into the zone again, sub-area by interior point, and grab the 1D zone that I'm aware of here. Use it, yes, and hit Enter. And there is your roughly the 22.9 acres then duplicated as it should be. And we have a calculated runoff of 0.8 inches, and that volume would store everything there. But remember, this is pre-construction. So I can make a report out of this and send it on with some header information, but I'll get out of there and hit Exit. That is all recorded. Restore my layers, and we have a 46 curve number by doing that method, and TC and peak flow, yeah, continue on and do that process. So when we come down over here, we've completed our curve numbers and runoff. In tune with that command as we work down. Remember, we do it twice. Automation. If you have distinct drawing, as we do for our building, roads, magenta drawing, let's go, about to take place. Go back to shed layers. We have a 65 default curve runoff number, and these other numbers defined up here in our table. So the white space will be defaulting to 65 curve. The others will respond to here. Now keep in mind, these will actually pay attention to the soil types automatically in the curve number calculation routine. Even though only one curve number shows here, it shows the A column by default. Remember, the woods were 30 for the good woods. This is a little bit, you have to understand this. It's showing the A column by default, but it's going to calculate all the soil types, composite the curve number up automatically with those layers defined using this command, curve numbers and runoff. Now, it would be difficult to do the existing and the final in the same drawing because it actually finds all frozen layers. So if I wanted to do the existing, instead of that pick one at a time approach you saw earlier and just had one big perimeter for the woods, I would have to have that in a separate position moved over to different coordinates or in a separate drawing, because it will find all layers thawed or frozen when it does this process. I only have the layers for my design working right now, so I repeat that command. I clear what I have previously. Hey, note, 46.6, pretty darn close to the 46.7 worked up in preparation for this. 0.8 calculated runoff, there it is. So these numbers are right there. We're now heading over to the post-construction condition. We're looking to get those two numbers. So we clear what's there and then do a much more automatic thing than the one-by-one interior point pick. We do the select watershed approach. We hit select watershed, look at the command line, perimeter or interior. I hit enter for perimeter and perimeter watershed. It calcs, it's doing all this sort of GIS level cutting in just a split second, and there you have all 4 soil zones of Woods Fair, not just the one in the list of soil type A, but you have all of them. Actually, I must be using Woods Fair in this condition as opposed to Woods Good for the post-construction condition, which may make sense with all the construction that goes on. No, this is the, yeah, this is the, I have a little bit of remaining post-construction condition on woods, apparently. And then we hit, we got these numbers here, and I got 59.3 versus 60.6. I got, let's see here, we have, that's very close, so that looks good. And look at our calculated runoff, 1.7 and 3.3. Let's take a look at what we had calculated, or yeah, 3.5. Basically, sources of the numbers did by just clicking the perimeter. All right. Now, the next step is going down the numbers in runoff, both ways, interior pick and where it cuts through everything, soil types and layers. Now we go down to time of concentration, and we do the SCS method. Now, some people would call this the objective method. There's a lot of subjectivity in the TR55, and Peter has sort of explained to us many times that this was almost a paper and pencil kind of cheat sheet approach before computers allowed the pure objective automation of the SCS method. Let me show you what I mean by the objectivity of this method. If I come in to the SCS method, I get a simple dialog. Where I'm starting with. Well, how about 46.7 for the pre-construction condition? My length of flow, I can pick flow line right there on the map. So I select the flow line and pick it. It finds that. Now this is neat. The average land slope, now that's not of the flow line. That's of all the land inside your watershed. That's where the automation of computers comes in. I select the surface data. I have a tin for this. I hit open and at perimeter, enter for perimeter and pick it. And there, I get that completely automatic, and I hit calculate, and there is my 0.8 hours time of concentration computed for me. That is the TC step. Now, we can basically stay in the command and go 60.6 for the post-construction. Let's say we have a similar total length of flow and a similar average land slope. It would change with post-construction, but in this example, I really don't have a post-construction DTM. Buildings and roads over a pre-construction DTM. So I just don't have one. It may change. There may be a different average slope. You would enter that, calculate, and you get your different time of concentration, 0.56. You see it there. We worked our way down through time of concentration. Now on to peak flow. Graphical method, very straightforward. Up comes the dialog. Let's focus on pre-construction. This is the all-important command that tells us what we're trying to get down to from the post-construction conditions. So we put in our curve number of 46 or 47, and we put in time of concentration of 0.8, and type 2 storm is pretty typical for a large part of the country. And when you calculate, we're looking for a CFS, and you can see just from slightly different area. I think I had 22.9. You know, you can get, things will change ever so slightly as you adapt up to the precise numbers. And so we have roughly 8 CFS is our target. Now staying in this command, let's walk down it. We're using it twice on the post-construction condition. Curve number has ramped up to 61. Time of concentration has slipped down. Things running off faster, 0.56, see if it takes 2 decimals. And I believe everything else is still good. I'm looking for around 30. Yeah, 30 CFS matching that condition. So having a little chart like this is very helpful in kind of working down through the software. And I know one or two of our programmers are listening in and kind of would like Detention Pond sizing command to actually build in some of the input commands process. Currently, it just uses the results of the watershed effort to plug in the numbers. So I put in my peak inflow discharge, which is, I'm going to call it 30.13 and kind of match what I did in preparation. I want to get this necked all the way down to 8.18 with a detention pond. And we saw this earlier. Our post-runoff condition, post-construction, is 1.8. And we go ahead and calculate the ideal pond size. And that's where we get the 1.4 acre feet. And 3.5 approximately, or 3.4, would store all the water if you didn't want to bother putting any spillways and over-design a pond and build something extremely large on the site. So that is the process that leads us to this point. Now, let's continue on down and the assignment. At the very watershed, I've got a little pond laid out, and I got to do design. We'll do that very quickly. We go to now the structure pull down, and we design a bench pond. I'm going to use a tin surface to do this with, and just hit OK. There's several options you can play with. And the top of the pond is just a regular polyline. It's a dumb polyline. It's at 0 elevation. It's just a perimeter. This is my tin file for the watershed. And I'm going to do an outslope of 3:1, an interior slope of 3:1. And I'm going to go from 815 down to 810. And here's my storage, and it tells you it's not big enough. 1.2 acre feet. I want about 1.4, 1.5. So I can adjust my parameters, not balance any cut fill. I'll keep my outslope the same. I'll make my interior slope 2:1, and I'll start at 815, but it'll go down another foot to 809. And I'll offset the dam? No. And now it recalculates. And notice I've increased it to 1.5. That's a little bit more than 1.4. And for those designers out there, it's a real challenge to get your spillway design such that the minimum pond it recommends works. I like a little margin, so I'm going to go to 1.5 and avoid the precise 1.4 absolute minimum size that could possibly work with the best spillway design imaginable. There's your volumes, and I'll hit exit. Adjust the parameters? No. Write a stage storage? Yes. And I can call it pond 2 capacity file. Update the target surface? No, but I could. Write out and trim contours? I'm not going to bother. Or contour the pad. I should point out to everybody, this thing can be moved. Be aware that you can edit a design bench. Provided it was designed against a tin as I did it, I can come in and pick almost any part of this thing, and you have a complete design world off to the left where you can, for example, move the pond to a slightly different position, rotate the pond, do whatever, reprocess, and it kind of dynamically places the pond in a new position. I can exit out of there, and all the pond parameters were there for you to work with. The pond has the same stage storage. Done the pond, I got to do multiple outlet design. So I come down here to the structure pull down. We did a design bench pond. We edited the bench pond. Bench pond is sort of a relic term from our mining days, but it's basically on the land, enclosed. Valley pond is an alignment across a valley which dams up a valley. It's a different approach. Very strong pond design all throughout Carlson Hydrology and Carlson Civil. From a DTM standpoint, perfect to feed into HydroCAD. Now, HydroCAD, very strong in very subtle and advanced outlet designs and even underground storage, and Peter's going to be addressing that after I finish my portion. But here's some just basic multiple that you can do. Make a new file called Pond 2. It's multiple outlets. Now here's what you might do. You might start an orifice, call it base flow, and you might say, let's go with a 6-inch orifice at 809 to keep the mosquitoes out and drain Headwater elevation of 815, as we know, and you can hit OK. You don't have to do your stage discharge on each segment of this, each piece of the, each element of the discharge. Wait till you're done with the entire process. So hit OK. Move on and add perhaps what you might call a principal spillway as a simple culvert. And what I'm going to do here, just sort of run a pipe right through the wall of this dam, of this little pond, and I'm going to make it corrugated metal and read from my library and pick up perhaps a 15 inch and stick it in there at 3 feet below the top, so I have 3 feet of freeboard. And outlet, I'll drop it 2 feet down over a length of 60 feet, and you get the idea how this works. It'll compute the slope, whatever that might be. Your headwater elevation is still 815, top of the dam, and you can kind of solve out what it's putting out there. Putting out 7 CFS, okay, and at a 15-inch dimension, starting at 812, that should work pretty good in combination. I want to keep it down around 8 total. So what I'll do, just for a little overflow, add an emergency, E-M-E-R-G-E-N-C-Y, weir, and I'll give this guy just a little tiny crest length, 1 foot below the surface, just to prevent anything from overflowing, and hit OK on him. And that's how you might put in 3 multiple outlets. Now you've got to hit the stage discharge here, because we need this as an input later. Water's at 809, maximum's at 815, increment maybe 0.2, and hit OK. And then this should calculate out the, did I hit OK? Should calculate out, there it goes, the stage discharge. And everything's drawn. Write that file. Don't forget to write it as Pond 2, STG. Whoa, that's on my speaker. That came a loud beep here, and we'll hit close, and you're good. And you're almost down the bottom of the list, and I'm pretty much on time to get there. Save the changes to the current file. Yes, everything's saved up. Okay, you can move over to the right. I like this command for you CAD guys. If you have stage storage, draw your stage storage on that little pond we designed live here. You could come over and select the file. There's everything there. Let's get your spillways lined up here. Principal was 3 feet of freeboard. Emergency was actually 1 feet of freeboard. And clean out's an arbitrary thing, but maybe you want to clean out from time to time. You can put in different header information. You can hit OK. It defaults some very nice intervals for the gridding that it's going to do. And then you can come over here to the right and get a beautiful 8.5 by 11 stage storage curve, fully labeled out in any kind. I've got a Arial font active right now for my title, so it's a little bit bold, but that's 8.5 by 11 to the limits of the, and one more convenient thing to submit. Hydrograph, I've got 2 more steps to go, and I've got 2 minutes to do it, because I want to give Peter plenty of time to take it from there. And I actually want to hit HydroNet for the total automation on the way out here. So very quickly, where do you go next? Well, you've done your pond designs and so forth. You go to Hydrograph Routing, because I want to get a hydrograph. So I go to the SCS method all the way through here, and I've got my acreage. This is my post condition I'm focused on now. These are the right values for the post condition. They're in there. They're correct. My base flow, I'm going to say, is 0. I've got my correct storm, and my time increment is fine. Pretty much everything was filled out for me, and I hit Calculate. And then I go to my runoff hydrograph, and there it is. And there's that same 30.1. Look how it's all sort of tying together. And I save this as Pond 2, okay? And then you close, and then the final reservoir routing to see how that pond actually did. is you come on down to Hydrograph Routing. You're done with your hydrograph by the SCS method. Slip on down to Reservoir Routing. It's all in that little list below. And you select your correct hydrograph, which is Pond 2, made just now. We have, if you want to use the actual files we just made, use Pond 2 capacity and use Pond 2 stage. And let's see how we did on the routed hydrograph starting at 809 elevation, time equals 0 water. And yay, what was our goal? To get down to 8 CFS. Got down to 7.7 CFS. I kind of over-designed just a little bit, but we got away with it, and we started with 31 CFS down to 7. This is the essence of the design inside the module. Now, for the finale of auto, a few steps, but it's not that many if you look at it. You just work your way down. It's all under your control. Now, this has been sort of integrated into the HydroNet Explorer. I go over to HydroNet Explorer, and I'll make a brand new one, and I'll call it Pond 2. And let me see if I can show the integration here. Just give me a second to make a. Do I have a list to pull down? Just give me a second to get my set. Give it a rainfall. I'll go to my rain map again. Pick on Kentucky. Go to 100-year, 24-hour. Pick about where I'm at. Get a rainfall event that in this case, I name as Maysville, and I save that, and it's here. I also go back to the general and make sure I get my surface file in there, though it'll prompt you if you don't do it. Much like RoadNet, you can't go forward if you don't have that surface 10. The rest is all good. One thing that's important is that we're going to use the curve number lag method. This is important to feed into HydroCAD because HydroCAD it adds to the automation to use that approach first, but you can also do TR55. Okay, you hit OK, and then this magic update button takes over at this point. With my watershed named 1S, because it's in the correct layer, as is my perimeter, everything's layered correctly according to that watershed top item. I just hit update. And I hit OK. I won't go to HydroCAD because Peter's going to take it from there. He's already done it. And we wait it out. Okay, how did I not get a subcatchment name? Looking for pond design or pond design webinar on layer subcat numbers. Created two sub. Oh, I'm sorry. That was my bad. I actually put my pond design webinar. If you don't mind, what I might do is just erase that. I don't know this is going to cause a problem at this point. I wonder if I can delete that one, remove it, and because of that layering, I actually got my actual factored in as a watershed, but I got the one I want over here. So that's sort of an illustration that it takes those layers very seriously. Right-click. Now this is a tree figure. Right-click and edit. And you can see that it actually has your hydrograph computed from the site automatically. And if you right-click the pond and add, I can, to this particular watershed, move it over to the right, grab my 2 capacity made just now, that's the capacity file, hit OK, and edit and grab my load my Pond 2 multiple outlet design, and I have those here, and now I can, just by the sheer act of loading those under the pond, which I right-clicked and associated with my 1S subcatchment, the one we've been focusing off the whole time, I have my before and after hydrograph. I've kind of necked them down a little bit more, down to about 7 CFS versus 8 in terms of the rainfall event I chose, etc. Maybe slightly less rainfall. And there's my stage storage, stage discharge. So steps earlier, and you still have to do the detention pond sizing one to figure out how low a flow you want to go to. But the point is, a lot of the steps in the pull downs were automated by this tree design of HydroNet Explorer, including the direct link into HydroCAD. So with that, to send it over to Peter Smart, and I'm going to do that by changing presenter, right? Oh, our IT person is going to do it for me. Over to you, Peter.
Okay, excellent. Thank you very much, Bruce. That's really a great look at some of the powerful capabilities in Carlson Hydrology of being able to do things like the pond designs and lay out that stage storage information. What I have here is now the file that you would generate when you export from HydroNet Explorer to HydroCAD. Then we can create a HydroCAD project file automatically, which has all of the information that you were working with. And we have here the subcatchment, the runoff information, and then the detention pond that you've designed, including all of the storage and outlet controls. And the first thing I want to do here to work with this in HydroCAD is to go to our calculation settings on the rainfall tab, and we want to look up the rainfall information for your particular location. And so if we come down by state and by county, we can pick up the particular info that matches, and let me see, 5.8 is the rainfall you had, so there's Campbell, Kentucky. I'm guessing that that's the county. And if we OK that a couple of times, we've set our rainfall, and now all the rainfall events have been automatically defined. And if we then double-click the pond, we get a report. What HydroCAD's done is it's automatically updated the calculations for all of the inflows to that pond. In this case, it's just this subcatchment. And we could double-click the subcatchment and have a look at the report for that particular point. So we have a fairly simple project here in which we've only got that one subcatchment inflow. But the model has automatically brought the inflow to the pond. That's the green inflow curve we're seeing here. And it's doing the hydrograph routing through the pond, producing this blue primary outflow down the bottom. This upper curve in black is actually the elevation of the pond versus time. And this report at the moment is showing us the 10-year event. If we drop down the box, we could go up to the 100-year event, and we can now see the routing results for that pond in any of those different return periods. We can also go to the events report and click update, and we have a complete table showing the inflow, the runoff for each of those return periods, and then the pond discharge and maximum elevation and maximum storage that's attained in each of those cases. There are a whole bunch of tabs here that you can use in order to examine not only the hydrograph, but you can look at the stage storage information. So this is based on the surface areas and contours that Bruce has extracted, and then the stage discharge curve. And this is probably one of the more interesting reports for the current discussion. What we're seeing here is an elevation range from the very bottom of the storage at 809 up to the top at 815. And labeled on this curve are each of our outlet devices. So at the very bottom of the pond, we have a low flow outlet, which I think was a 6-inch orifice. Then we have a principal culvert outlet, which is placed at an invert of 812, and then finally we have an emergency spillway up at 814. And then our storage is defined a little bit higher, and that's very important that you always define storage at some point above the spillway, because the software does need to know how much storage you have as you start to flow over the spillway. And again, the storage tab would tell us the actual storage that exists versus elevation. So on the discharge tab, actually let's go back to the hydrograph. We have a single primary outflow which combines the flow from all of these outlet devices. One of the nice things we can do in HydroCAD is we can edit this node, and we just click the edit button to do that. Come to our outlets tab, and here's the list of outlet devices for this particular pond. And let's go to our emergency spillway and double click that. And I'm going to change the routing on the emergency spillway and just set that to secondary. So this will split out the flow so that it will do a separate analysis of what's going over the spillway versus our normal outlet devices. And click OK. And our report is now updated to show a new red secondary outflow. So this is telling us how much is going over the spillway, which is a very handy thing to know, versus how much is going through our normal outlets. And if we were to reduce our rainfall down to the 50-year event, now we don't get anything going over the spillway anymore. So that's just to show one of the advantages of splitting out those flows. Even though the total routing calculation is the same, we get separate reporting, as you can see here, for what's coming out through our primary and our secondary outflow. And here on the pond summary, we have an overview of all of the information for this pond. So this is the surface area at each contour elevation that Bruce has exported, and then the storage that's been calculated, and then a list of all of the outlet devices that have been set up. And what I want to do next is make some changes to those outlet devices. In this example, we have a straight culvert barrel going through the dam wall. And often you'll want to set up a more elaborate structure such as a riser or a drop inlet in order to provide more detailed management of the discharge characteristics for different rainfall events. So I'm going to come back to the stage discharge curve because here we can see the effects of the different outlets. We have our emergency spillway in red, so that doesn't kick in until 8:14, and then our primary discharge consists of this low flow orifice and a culvert outlet. So what I want to do here, just switch to the 2D view so that you can see that a little more sharply. And let's edit this pond. And I'm going to go into the Outlets tab. And I'm going to build a riser structure. Now we already have a culvert outlet on this pond. So let's actually use that culvert outlet. And I'll double click that to edit. And now I'm going to lower that culvert outlet. So rather than having it up at 112, I'm going to move it down to 110. Put it close to the bottom of the dam wall, so I'll just lower that, and we can click OK. And if we were to apply that as is, you will see the change over here in the rating curve. You'll see it's moved the culvert down to 810. We've got a new rating curve and a new routing operation. This little kink, by the way, is occurring when the pipe fills completely, when the hydraulic radius increases more rapidly than the wetted area. And so there's a slight discharge, a decrease in discharge. So now let's edit. Actually, we've already set up, we've lowered the pipe. Let's also increase the size of that pipe. If that's going to be a barrel coming out of a riser structure, let's bump that up to 24 inches. And again, we can click OK just to look at the result. We don't have to, but you will see this immediate update that we get a more rapid increase in storage. So now if we're going to build a riser structure, this culvert is going to be the outlet barrel from that riser. What we can then do is to set up each of the flows that's going to come into the riser structure from the side. And we've got detailed articles on the website that talk about the setup of these riser structures. Often there's something like this with a culvert barrel and then a riser that's got openings in the side as well as an opening at the top. And the procedure for modeling these is to set up that final device first, and that's the culvert barrel that we've already set up, and then to create the side and top openings and route those through the primary device. That's really the key. And in this case, it's device number 2 is that culvert barrel. So let's create a new outlet device. We'll go to a blank line, and let's set up an orifice, which is going to be the top of our riser structure. So we want to put this orifice up at 812, let's say. So it's partway up into the pond. And let's make this a 6, actually let's do an 18-inch diameter for the top of the riser. And we want this to be in a horizontal plane. So this is the top opening. And the software will automatically consider weir flow over the top under low head conditions and then ultimately transition to orifice flow if it should get deep enough. And the key on this screen is that we want to change the routing. And we want to specify that the flow after it goes through this orifice is going to go through device 2, which is our culvert. So moving this aside, device 2 here is that culvert. And if we click OK on this, and actually before I do that, I'm just going to label this. I'm going to call this top of riser just so the reports are clear. And click OK, and we added that outlet device. And then we can click apply, or OK in this case, and it updates our stage discharge report. So now if you look closely at this, what you're seeing is that we still have this culvert barrel at 810, but it's not contributing any additional flow at that point, because in order for water to get to the culvert, it has to go over the top of the riser first. So we only see that increase in flow once we get over the top of the riser. Then when we get enough flow over the top, we actually see a point of inflection here, which is where the culvert barrel may be starting to limit the flow through the system. So this shows you how you can update the reports very easily. So we could now go back again to our outlets, and we could put in a side opening. So perhaps this is handling the 10 or 25 year storm. So we could do another orifice. We could put this in at 811. This one is going to be in a vertical plane because it's a side opening. And let's set a diameter of 6 inches and set the routing to device 2. Again, it's going to go through the culvert barrel. And now if you watch the stage discharge curve as I OK this, you can now see we have a slight point of inflection here, so that when we hit that 6-inch orifice in the side, we get a little bit more flow. Then when we hit the top of the riser, we get a lot more flow. So this is the process you can use to build basically any kind of compound outlet structure in HydroCAD. You can combine these devices in order to model almost any kind of more complex element that you may have. And coming back to your pond summary, we can get a full breakdown of all of the outlet devices that we have in this pond. And this diagram down the bottom shows you the flow, that we have this opening in the side and then the top of the riser, that those flows are being combined and going through this culvert barrel, and then those are in turn combined with a low flow orifice that we have on the entire pond, and that constitutes our primary outflow. The secondary outflow consists of just an emergency spillway up top. So that's a basic look at what you can do with ponds. There's a lot of other features in here. There is a pond sizing report that you can use to estimate the pond size that you need to attain a reduction in peak to your pre-development flow. That's very similar to the sizing calculations that Bruce has showed you. And of course we can go to our events tab and click update and get a full analysis of that pond for each of these return periods. So that's essentially what I wanted to show pertaining to outlet devices on ponds. In this example, we have an above-grade storage pond that's been constructed by grading, and it's great to be able to extract that data from your terrain model and bring that from Carlson into HydroCAD. Another situation that comes up very frequently, more and more often, is underground storage. So rather than putting your water in an above-ground pond, you're going to build an underground storage facility of some type. And there are a number of different ways that you can model underground storage in HydroCAD. You can actually take any of the standard storage options that are available, and those could be used as underground storage. The most common of those would be perhaps a horizontal cylinder or a pipe. So you could have sections of pipe, perhaps constructed with manifolds so they're hooked together with an outlet control device, and you could bury that underground and use it as pond storage. And you would do that by selecting the pipe storage option in HydroCAD. You can also set up underground storage chambers, and basically storage chamber capability lets you model the various proprietary storage products that are on the market. We're adding more of these almost every month now. Cultec, StormTech are some of the more commonly known ones, but there are many other different products out there. Some are square milk crate type chambers, others are arch chambers. And you can examine the chambers that are available by, in HydroCAD, just clicking the library button and going to the chamber library. And here's a full list of the chambers that are installed. So you can pick a particular chamber and see a storage cross-section for that particular chamber. You could compare that to a different model or manufacturer. And this library even includes corrugated plastic pipe, which provides storage, corrugated metal pipe, concrete. There is an enormous range of different options. And it also includes arch pipe, which actually is very interesting because you can approximate a lot of the chamber shapes using arch pipe. So this viewer is basically just to let you see what's available in the library and lets you compare the different kinds of storage chambers that are available. in HydroCAD itself, when you're setting up a model, and this is an example which is shipped with HydroCAD showing pond storage, there are two basic ways you can set up underground storage. You can set it up manually. So in this particular scenario, going to the pond summary, we have an outer field, an excavation, in which we're burying these chambers. So we have set up 100 of these chambers, and we've calculated the dimensions of the outer field, which are needed in order to encompass those chambers, because we need a certain amount of stone in between them, under them, on top of them, and around the sides. So we sit down, do a few calculations, and we set up the outer field in which we want to put those chambers. And if I can show you how we do this when we're editing, if we go to the Storage tab, here's the outer storage field, and this is just a prismatoid, so it's just a box that we've created. And then we've selected the particular chamber that we want to embed, and we specified that we're embedding that chamber inside volume number 1. So this is the magic that puts the chamber inside the stone bed and displaces that amount of stone. And we can pick, of course, the specific chamber that we want to use, and we can go back to the chamber viewer where we just were and look at the cross-sections for different chambers. And so the software does the calculation of embedding that chamber inside the stone and then allowing for the voids in the stone, 30 to 40%, and calculating the storage that results. And so we then have a stage storage curve, which is this blue curve on the left, and what it's showing us is that down the bottom of the system, for the first 6 inches, we just have storage in the stone. Then we have the base of our chamber, and we have chamber storage, and then finally we have storage in the stone cover, and then perhaps even above grade storage as the system overflows for a larger storm event. So that stage storage relationship is automatically calculated, as is the area of the system. This can be a wetted area or a surface area, which can be used to automatically calculate exfiltration from these systems. If we go to the Discharge tab, this shows that we may have a culvert used for a high water overflow, but that we may be handling the lower events by exfiltration or infiltration into the surrounding ground. And so those two rating curves are used to do the final hydrograph routing calculation. So here we see our inflow in green, and then we have this discarded outflow in brown, which is our exfiltration, and then finally a overflow through the culvert if the water level gets too high. In HydroCAD 9 onward, we have a new chamber wizard that makes this process much, much easier. And what you do with the wizard is you basically just pick the chambers that you want, and the system automatically lays out the field. So going into the report, here's the output of a typical wizard design showing a storage field and a complete analysis of that field. Setting up those fields is really easy. Just to show you, I'm going to drag in a brand new pond, so there's no preset data here, and we'll double click to edit that pond and make it a detention pond, and then go to the Storage tab, double click to create a new storage option, and rather than picking one of the basic fundamental storage objects, we'll pick the chamber wizard. With the chamber wizard, we can now pick the particular chamber that we want to use in this system. So we can come down here and pick anything we like from this particular list of chambers, and there's a cross-sectional profile of a single chamber. Then what we can do is increase the number of rows in our system or the number of chambers per row, and this lays out a grid with the specified number of chambers. Now we do need to put stone under these chambers, between them, and on top of them for structural reasons as well as the storage it provides, and we can set those parameters over here. So we can increase the row spacing, we can increase the stone underneath the system, or we can just click the box up here to use typical spacing, and this will preset all of those parameters to the manufacturer's recommendations. So we have now designed a complete system using these 9 chambers with the necessary stone that's around them, and this is a complete analysis of the system. We can even put in the cost for each chamber, put in excavation costs and stone costs, and get an estimated cost for the whole system. When we click OK on this, HydroCAD, or the wizard, has now created automatically these 2 definitions. It's got the outer stone field and it's got the embedded chambers. Click OK again, and then if we double click our pond to open up a report, we have a complete storage calculation for that system. So we have the stone field at the base, storage in the stone, and then the chambers, and then the stone cover. And if we needed more stone in that system or more storage, we can just click Edit, go to Storage, double-click to reopen the wizard, and we can increase the number of rows or the number of chambers per row until we get the total storage that we want. So we have our total here of 9,387 cubic feet. And just OK twice, and our report is automatically updated. And of course, we could have an inflow coming into that from our runoff system. But this is to show you how quick and easy it is to set up those storage definitions using the wizard, and you can combine these, of course, with other storage elements. So you may have storage contributions from an adjacent manhole, a pipe system, or even above-grade storage in a parking lot as your stormwater overflows. So that's a quick look at underground storage and the storage wizard in HydroCAD. That's essentially what I planned to cover today. Are there any questions, or Bruce or Gary, are there any other things that you'd like us to have a look at?
Well, go ahead.
No, you go ahead, Bruce.
Well, my comment would be that there is so much subtlety and advanced features within HydroCAD that it just makes a perfect combination with the basic DTM and layer-based data extraction features of the Carlson side. You might say that any level of pond design can be accomplished on the HydroCAD side with meeting jurisdictional requirements all around the country through the history of that product in the marketplace. So we're just very excited to be working with Peter Smart and to be able to link effectively to his software and provide the input data for that very high level design that occurs on his side.
Yeah, boy, that was just great, guys. I just very, very exciting, and just a great, just to see the two working together. I think this was awesome. We're right at about 1, so we only have a couple questions. Let me just go through these quickly for you guys. The first one, I think, Bruce, when you were doing your presentation, a question came up about the standard types of rainfall distribution, the 1, 1A, 2, or 3. Is there any way to adjust or assign new distribution other than those standard types, was a question that came in.
I don't know if Shan Lu is online with audio, but she might be able to address that better than me. I do know that we have, under the network pull down, under sewer network libraries, the ability to define 7 different types of rainfall events, not all of which apply to this SCS pond sizing, but we have the TP40, which was, I believe, the method we were using. We have the Hydro 35, and of course we have IDF curves, rainfall intensity charts that you can enter, and so we have a variety of methods of entry, but I'd have to sort of defer really to Shan on that question. Okay,
and then and that's great, and also the choice there too is to do the rainfall. And Peter, I think you're showing some of how HydroCAD can deal with that question.
Exactly. We've got an extensive rainfall library in HydroCAD that provides most of the local rainfall distributions that folks are using in specific jurisdictions, and in addition to the standard NRCS or SCS distributions. And you can set those rainfall depths according to TP40 or other documents. We also have coming the ability to automatically import complete rainfall information from NOAA's precipitation data server, and also from a new New England data server, which is now coming online. And this process will automatically generate mass curves for any point on the map. So we're actually moving towards complete GIS-based, location-based integration and this is going to gradually phase out the Type 2, Type 3 rainfalls is what it appears, that they were done in a very general manner in the 80s, and we now have much more data to go on.
And Gary, I would add to that we didn't emphasize enough that quite frankly, in the HydroCAD side, the rainfall itself can be HydroCAD can be the source of the rainfall distribution information. So when we link over to HydroCAD through the HydroNet Explorer, that link basically focuses only on the cutting of the layers to produce the composite curve numbers for the watershed, and the DTM aspects that give length of flow, watershed average slopes, all the sort of DTM and layer-based input that's necessary. But every other aspect can be done on the HydroCAD side, including the rainfall.
Yeah, absolutely. I think again, I just keep repeating myself, but the partnership, between the capabilities of the two softwares is so exciting. I think we've got everything covered between the two that anyone needs to do. Real quick, question, Peter, when you were doing the pipe, the riser, and putting in the additional parts of the pipe there, the question was if it's a perforated pipe, basically. Simple question, which I'm struggling, I should just read it. If it's a perforated riser, do you have to add a structure for each hole in the pipe, is the question.
What you can do is you can use what I refer to as an orifice array. So going back to the side orifice we had, if that was just, let's say, a 1-inch hole, we could specify the number of openings we have, and this can include columns. So if it's perforated up, we'd specify that there are 8 rows, and we could put a 2-inch spacing between the rows. So that's the way you'd handle a perforated pipe, and just click OK, and we're all done. And we now got those perforations right up the side of the riser.
Great, thank you. Excellent. That's really all the questions. You guys did such a good job. I think you covered things extremely well. And by the question list, that appears to be the case as well. There is a question, is if it will be posted on the website, and absolutely. They're all recorded. They're up there on carlsonsw.com. And over on the right, you'll see movies. It'll be under hydrology. It'll probably be up there by later this afternoon, or certainly by tomorrow. Let's see. I didn't see how things we did in Carlson went into HydroCAD. And basically, there was just in the HydroNet Explorer that Bruce was in. The only thing he didn't do there at the very end was just click the button. There's a little button with a HydroCAD logo on it, and it basically is the export to HydroCAD. So it was just a button click that was not done. That basically exports the file. It's an HYN file. It goes right into HydroCAD, and then Peter basically took that file and took it from there. And since they're in different locations, Peter's in New Hampshire and Bruce is in Kentucky, rather than, I was actually crossed my mind to have Bruce actually email him the file. I thought that would be interesting, but without taking the time to do that, we basically gave Peter the file ahead of time. But that was just, there's an export to HydroCAD that Bruce is showing right here. That's in the update. You can do it there. Or if you don't do it, if you want to do some calculations and not export it, then you can do it after the fact. All the way on the left there, Bruce, is the little rain cloud logo, and that will do the export to HydroCAD right there. So thanks for that question.
Yes, and if I could add to that, Gary, a very important feature we have is that as your site plan changes and you change your terrain or you remap your soils or whatever the change may be, you can automatically update that information in Carlson by clicking that update button, and the updated information is sent to HydroCAD and merged into the project in an intelligent manner. So you don't lose any other custom work you've done in HydroCAD if you've done pond designs over there, for example. So there are products out there that will do this extraction, but when you make a change, it's where you see where they really shine. And so we were insistent that we wanted this automated update to really work well, and it does.
Yeah, absolutely. That's great. Thank you. And boy, guys, I wish we could keep going. We've had a great crowd. You had about 95 people on board today. We're down to about 70. I think they got to get back to work, but just a great presentation. We'll follow up. We'll put our heads together, figure out what to show next, but we really appreciate everybody's time. I'm just going to put out, my email is grosen, GROSEN, @carlsonsw.com. Feel free, anyone, to to email me with further questions. I will make sure they get to the right people. And if you'd like to demo the software, of course, please let us know, and we'll do everything we can. We're very excited about this, and we appreciate everyone's time today. Is that it, guys? We all set?
That's excellent. Thank you both, Bruce and Gary.
Absolutely. Thank you.